Okay, I'll be doing an induction problem on this one. Okay, so this is the statement we want to prove. So first we give it a name. Let's call it P of n. The statement for n, that's 1 over 2 factorial plus 2 over 3 factorial n over n plus 1 factorial equals 1 minus 1 over n plus 1. This is the statement factorial. This is the statement we want to prove, so we name it P of n. Now for a base case, that's for n equals 1. Let's calculate the left side of P of 1 over 2 factorial. That's what it is. So n is 1, so we stop at 1 over 1 plus 1 factorial. This is 1 over 2. And the right side is 1 minus 1 over 1 plus 1 factorial. 1 minus 1 over 2 factorial. This is 1 minus 1 half. And this and these are equal. So P of 1 is true. The base case is true. Now induction assumption. Suppose that P of k is true. That is, we suppose that 1 over 2 factorial, 2 over 3 factorial, if we add them up to k over k plus 1 factorial, we get 1 minus 1 over k plus 1 factorial. Suppose this is true. Then we want to show that P of k plus 1 is true. This means that we want to show that 1 over 2 factorial, 2 over 3 factorial, k plus 1 over k plus 1 plus 1 factorial equals 1 minus k plus 1 plus 1 factorial. Okay? So let's figure out, let's check the left-hand side. So the left-hand side of this statement is 1 over 2 factorial, 2 over 3 factorial, 3 over 4 factorial, k over k plus 1 factorial, k plus 1 over k plus 2 factorial. Yes, because that's the one before it. Now, this is the left-hand side of P of k. This is this guy here. We assume that that's equal to that one. So we'll replace that. That's 1 minus 1 over k plus 1 factorial plus k plus 1 over k plus 2 factorial. This is by induction assumption. Okay? Let's see what we want. We want to get that. So the common denominator is k plus 2 factorial. We get k plus 2 factorial here over k plus 2 factorial minus, this is missing k plus 2, plus 1 or k plus 2. No, let's save the 1. Let's save the 1 because I want that 1. All right, I'll save the 1. I'll just combine these two. 1 minus or plus this is what I have. But k plus 2 factorial is k plus 1 factorial times k plus 2. So the common denominator between those two is k plus 2 factorial. So I'm going to put 1 minus of k plus 2 plus k plus 1, which gives me 1 plus minus k minus 2 plus k plus 1 over k plus 2 quantity factorial. And the top gives us just negative 1. Or just simply 1 minus 1 over k plus 2 factorial, which is the right hand side of p of k plus 1. Hence, p of k plus 1 is true. Okay, so by induction, the statement p of n is true for all n, for all n greater than, for all natural number n. That means that 1 over 2 factorial, 1 over 3 factorial, 2 over 3 factorial, 3 over 4 factorial, n over n plus 1 factorial is 1 minus 1 over n plus 1 factorial for all n in list of natural numbers. All right.